Earth's other moon and its crazy orbit could reveal mysteries of our solar system. This is by Duncan Forgan, Research Fellow, University of St. Andrews in England, on The Conversation. We all know and love our moon. We're so assured that we only have one that we don't even give it a specific name. It is the brightest object in the night sky, and amateur astronomers take great delight in mapping its craters and seas. To date, it is the only other heavenly body with human footprints. What you might not know is that the moon is not the Earth's only natural satellite. As recently as 1997, we discovered that there is another body. There's another moon that the Earth has. It's 3753 Kruthne. It's what's called a quasi-orbital satellite of Earth. This simply means that Kruthne does not loop around the Earth in a nice ellipse in the same way as our moon, or indeed the artificial satellites we loft into orbit. Instead, Kruthne scuttles around the inner solar system in what's called a horseshoe orbit. To help understand why it's called a horseshoe orbit, let's imagine we're looking down at the solar system, rotating at the same rate as the Earth goes around the Sun. From our viewpoint, the Earth looks stationary. A body on a simple horseshoe orbit around the Earth moves towards it, then turns around and moves away. Once it's moved so far away it's approaching Earth from another side, it turns around and moves away again. Kruthne from a stationary Earth position. Horseshoe orbits are actually quite common for moons in the solar system. Saturn has a couple of moons in this configuration, for instance. What's unique about Kruthne is that it wobbles and sways along its horseshoe. If you look at Kruthne's motion in the solar system, it makes a messy ring around Earth's orbit, swinging so wide it comes into the neighborhood of both Venus and Mars. Kruthne orbits the Sun about once a year, but it takes nearly 800 years to complete its messy ring shape around the Earth's orbit. Kruthne close up. So Kruthne is our second moon. What's it like there? Well, we don't really know. It's only about 5 kilometers across, which is not dissimilar to the dimensions of the comet 67P Churyumov-Gerasimenko, which hosts the Rosetta orbiter and the Philae lander. The surface gravity of 67P is very weak. Walking at a spirited pace is probably enough to send you strolling into the wider cosmos. This is why it was so crucial that Philae was able to use its harpoons to tether itself onto its surface, and why their failure meant that the lander bounced so far away from its landing site. Given that Kruthne is not much more to us at this point than a few blurry pixels on an image, it's safe to say that it sits firmly in the middling size range for non-planetary bodies in the solar system, and any human or machine explorers would face similar challenges as Rosetta and Philae did on 67P. If Kruthne struck the Earth, though, that would be an extinction-level event, similar to what is believed to have occurred at the end of the Cretaceous period. Luckily, it's not going to hit us anytime soon. Its orbit is tilted out of the plane of the solar system, and astrophysicists have shown, using simulations, that while it can come quite close to us, it's extremely unlikely to hit us. The point where it is predicted to get closest is about 2,750 years away from today. Kruthne is expected to undergo a rather close encounter with Venus in about 8,000 years, however. There's a good chance that it will put paid to our erstwhile spare moon, flinging it out of harm's way and out of the Terran family. And it's not just Kruthne. The story does not end there. Like a good foster home, the Earth plays host to many wayward lumps of rock looking for a gravitational well to hang around. Astronomers have actually detected several other quasi-orbital satellites that belong to our Earth. all here for a little while before roaming on and onto new pastures. So what can we learn about the solar system from Krithna? Quite a lot. Like the many other asteroids and comets, it contains forensic evidence about how the planets were assembled. Its kooky orbit is an ideal testing ground for our understanding of how the solar system evolves. Under gravity, as I said before, it was not until the end of the 20th century that we even realized that bodies would enter such weird horseshoe orbits and stay there for such a long time. The fact they do shows us that such interactions will have occurred while the solar system was forming, because we think terrestrial planets grow via collisions of bodies of Krithna size and above. This is a big new variable. One day Krithna could be a practical site for landing humans on asteroids and perhaps even mining them for the rare earth metals our new technologies desperately crave. Most importantly of all, Krithna teaches us that the solar system is not eternal, and by extension, neither are we. On Wikipedia, and we have some beautiful here diagrams and simulations of what Krithna does in its orbit. Here we go, it's starting here. There we go. Animation of Krithna orbit from the year 1600 to 2500. Look at this. Isn't that something? Amazing. Very strange. Very strange. Very strange. It's just amazing. And it goes back. Okay, and then the bottom one here we have Krithna and Earth seem to follow each other because of a 1-1 orbital resonance. Amazing. It's 5 kilometers diameter, as we said. Closest approach to Earth is 12 million kilometers, about 7.5 million miles, approximately 30 times the separation between Earth and the Moon. From 1999 through 2015, Krithna made its annual closest approach to Earth every November. It's a normal elliptic orbit around the Sun. Its period of revolution around the Sun, about 364 days at present, is almost equal to that of Earth. Because of this, Krithna and Earth appear to follow each other in their paths around the Sun. It's why Krithna is sometimes called Earth's second moon. But it does not orbit the Earth and is not a moon. Krithna will come within 0.09 AU of Mars. Due to high orbital eccentricity, the distance from the Sun and orbital speed values vary a lot more than the Earth. Here we have another one. Appears to make a bean-shaped orbit from the perspective of Earth. Isn't that something very strange? The similar minor planets. This is the example of the horseshoe orbit. There we are. It's starting again. The Earth is the blue. Very strange. It doesn't close here, you see, it goes back, but what makes it go back like that? What makes it go back? That's the Earth, that's the Sun, and that's the asteroid, that's the the minor planet. It does not close the loop, it's a horseshoe, it's open there. Very strange. I'll leave links below for you for this. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.